Hey everybody, and welcome to heat transfer. We're going to do a quick problem here that's almost like fluids, which is finding the point in a boundary layer where a transition occurs. Now we're assuming that the Reynolds number where a transition happens is going to be 5 times 10 to the fifth. We have air moving at 1 meter per second out here in infinity, and then we have air at 27 and 77 degrees C. For this problem, we were supposed to do it for air, engine oil, and mercury. I'm just going to go ahead and do it for air because engine oil and mercury are exactly the same. You just grab the constants from the table that apply to these two. But it's not any harder, and it's not going to help you at all. So what happens, what we're talking about here is the transition point. When you have like a plate moving through air or air moving over it, right when it starts, it's laminar flow. It's flowing very perfectly from the tip, but then it kind of speeds up as it gets farther and farther away, and it becomes turbulent when it hits the speed of our transition. So solving this problem here, what you're going to do is we're going to use the equation xc equal to r xc c times theta all over mu infinity, which is the velocity at infinity. It's kind of a weird notation, but it is. But this is the R Reynolds number of transition, the critical Reynolds number, which in our case is 5 times 10 to the fifth. So if you go ahead and look back in the tables for the properties of air at certain temperatures, if you look at air at the temperature C, we've got 27 and 77 degrees C. I'm going to change that to Kelvin, which is going to be 300 Kelvin and 350 Kelvin. If you look for beta there, which is times 10 to the negative 6, the values, you'll have 15.89 meters squared per second and 20.92 meters squared per second. So these are the values that we get to use. So from this point on, it's pretty much just plug and chug. So the location, the x location from the tip, I'm going to go ahead and redraw this here real quick. Over here, xc from the tip is going to be this equation up here. So xc at 27 degrees is going to equal 5 times 10 to the fifth, which is our critical Reynolds number, times 15.89 times 10 to the negative 6, all over 1 meter per second, which is u infinity. Out here in the world, everything else is moving at 1 meter per second. If you calculate that out, you'll end up with 7.95 meters at 27 degrees C. So pretty easy there. And then at xc at 72 degrees, we've got 5 times 10 to the fifth times 20.92 times 10 to the negative 6, this value up here, all over 1 meter per second is equal to 10.46 meters at 77 degrees C. So that's our answer. So this is the distance from the tip where transition occurs in the boundary layer of the flow. And then if you were to do it for engine oil or whatever, you go ahead and look at engine oil at these temperatures, and you go ahead and everything cranks out, and it's just plug and chug really. So pretty easy problem finding the point of transition for a specific Reynolds number. As I said, R E x is equal to 5 times 10 to the fifth. This is a number that's kind of based on the discretion of your professor. This is the one that my professor gave me. Yours may have a different critical Reynolds speed that he wants you to use. So this value can change from one place to another. Don't hold me to that because it will be different for your class problem.